In this video, we're going to be going through the October-November 2024 paper 11 question 3 problem. And just looking at the diagram, we can see that the diagram has a sector, right? So we've got this big sector BOC or OBC, which goes from the center all the way out, and then that radius is 15 centimeters. And then you have that arc, but we also have this other smaller arc that's here, that's defined by AD, right? That's been cut out of that sector. And then we have the shaded region that's left inside there. So just looking at the problem, we can kind of see that this is a circular measure problem, right? Even before we read the question. But let's go ahead and read the question. It says the diagram shows a sector of a circle with center O, where OB is equal to OC, which is 15 centimeters. And we can see that, right? Because this, right? This is our radius, right? That is also our radius over there. And they create the arc BC. Or at least they create, the arc of that sector is going to be BC. Perfect, right? So that's OB and BC are the radii of the same sector, so it makes sense that they're equal. Perfect. Next, the size of the angle BOC is 2 pi over 5 radians, right? So which means this angle over here is 2 pi over 5 radians. So just so that it's not too crowded, I'm going to remove this. But let's just highlight that. Let's just make this a bit thicker, and then we'll go, size of the angle BOC is 2 pi over 5 radians. Right, now we're going to pause here. Remember, the moment you read the question and the question says radians, whether it's circular measure is usually going to be in radians, right? But whether it's circular measure, trigonometry, whatever it is, you stop and then you look at your calculator and make sure that your calculator is set to radians and not degrees, right? Because that's a source of errors. So make sure that your calculator is in radians. I always want to make sure that I emphasize that. All right, cool. So let's go ahead with the question. Points A and D on the lines OB and OC respectively are joined by arc AD, right, which we saw. But we don't actually have the radius of that arc, which is going to be a problem, right? So I'm assuming that's one of the things that we're going to need to calculate. Right, of a circle with center O, right? So these two arcs have the same center, right? The shaded region is bounded by arcs AD, BC, and the straight lines AB and DC, which we can see, right? So there's this line, that line, that line, and that line. Perfect. All right. Now, I think that is, it is given that the area of the shaded region is 209 pi over 5, right? So that's very interesting. Okay. Now, question is, find the perimeter of the shaded region. Keep your answer in terms of pi. Okay, now what we are going to do is we're going to approach this question by writing the formula of the perimeter and then breaking down what we don't have in the problem, right? So in order for us to get the perimeter, we'd need the arc AD, and then we need to add the line DC plus the line AB, right? Because essentially for the shaded region, all you just need to do is add up all the lines that enclose that area, right? So that's DCAB, right, which is these two lines plus the two arcs. So also add BC. All right. So let's take the easy ones, right? Which ones can we actually calculate right now as it is, right? We can actually calculate BC, right? Because BC is equal to half r, sorry, not half r squared theta, sorry. It's radius multiplied by theta, because this is arc length. Arc length is just the radius multiplied by the angle, right? Because the reason why I say we have this information is because we have, for that sector, we have the radius, which is 15, right? And then we have the angle, which is 2 pi radians. So just multiply those two. 2 pi over 5 radians, rather. Right, so multiply those two. So 5 over, this goes into 15 3 times. So this should actually give you 6 pi, if I'm not mistaken. 5, 15, 30, 30 over 5 is 6. Cool. Solid. All right, so we have this, right? So this is actually taken care of. BC is taken care of. What's next? All right, so the next one is going to be AD. Now, in order for us to find AD, we need this radius over here. right? We need the radius OD because we need to, for AD, for the arc length AD, we just need to apply the exact same formula, r times theta, right? We have the theta, it's still the same angle, right? It's 2 pi over 5 radians. But what we don't have is the radius, all right? So cool. And then same thing with the BC and the AB, because we can see that, I mean, DC and AB, because we can see that DC is actually going to be the radius of this, 15 minus the radius of this smaller circle, this smaller arc. So the radius of that smaller arc is what is stopping us from being able to calculate the three things that we don't have. So we're stuck. However, we're given a piece of information, which is this. The area of the shaded region is 209 pi over 5 square centimeters. So maybe let's use that, right? So we are going to draw, maybe I'm just going to take this back. So area of the shaded region is equal to, for us to get the shaded region, we would need the area of the full sector minus the area of this smaller sector over here. So the area of sector OBC minus whatever we remove from there, which is this smaller one, the area of sector OAD. All right. So how do you get the area of, actually, let's just write down the formula in general. The formula of the area of a sector is half r squared theta. So in this case, for the sector OBC, we have half. We still have the radius, which is perfect, right? So the radius is 15. So we can just say 15 squared multiplied by a theta, which is 2 pi over 5 radians. Just make sure that's correct. 2 pi over 5, yes, minus. And then the area of the other sector is going to be half of the radius squared, which we don't have, right? So we're going to call this length r, right? So that radius we don't have, but we do have the theta, which is 2 pi over 5 radians. Okay, so that's going to be your area. Your area is, the answer for that is 209 pi over 5. So what I'm actually going to do in this case is I'm going to factor out some things, right? So just to simplify our problem a little bit, just to make it look a little bit prettier, right? So what I'm going to do is I'm going to say, because we're giving answers in terms of pi, right? We just need to get, let me just highlight that actually. We actually need to make sure that we get exact values as we go, right? So the best thing to do there is just to be careful with how we work things out. Right, so what I mean by that is this. Okay, so we still have 209 pi over 5 on this side. On this side, we're going to factor out common terms. So this term has a half. Ooh. This term has a half. This term has a half. We can factor that out. All right. This term has a 2 pi over 5. This one has a 2 pi over 5. It looks like I'm cancelling out, but I'm just highlighting the common terms just in case that's confusing. So what we want to do is we want to factor those two out. So we can factor out half, and we can also factor out the 2 pi over 5. And what we're left with on this side, I'm just going to draw big brackets, is the 15 squared, because that's the only one that's left over here. And then we still have the minus sign, and we have r squared left over here. Okay, so that means now we can very cleanly divide this side by half, 2 pi over 5. But whatever we do to this side, we have to do to that side. So we have to divide this side by half, 2 pi over 5 as well. Okay, or if that looks confusing a little bit, right? At least like the whole dividing by half or whatever, we can actually just, as we are here already, just divide both sides by 2. So the only thing you're left on this side is pi over 5. So now we can now divide both sides by pi over 5. Divide that by pi over 5. Okay. So what this does is on this side, we're left with 15, because this cancels on this side. We're left with 15 squared minus r squared. On this other side, right? So this kind of now looks confusing. Right, this looks like a big fraction. However, what we can do is we can just write it on the side here and say, okay, this is the same as saying 209 pi over 5 divided by, because we divided both sides by pi over 5, right? But this is the same as saying 209 pi over 5 multiply, because remember, multiplication of a division of a fraction is the same as saying multiplied, but you now have to find the inverse of that fraction. And what that allows us to do is to cancel this 5, and then the pi's can cancel out. So that means the only thing we have left on this side conveniently is actually 209. So now I usually like my unknown number to be positive, so I'm going to take this value, take it to the other side. So the r squared, when it comes to the side, is going to become positive r squared. Your 15 squared didn't move. It's still exactly where it is, but now the 209 needs to come to that side. So we have negative 209. So that means your r squared is equal to, or at least your r is equal to, you root both sides just to get rid of this. Because remember, you're trying to isolate your r. So that means your radius, the radius we've been trying to find, is actually equal to the square root of 15 squared minus, I'm hoping this is going to be a decent value. The answer is 4. Perfect. 4 centimeters. All right, perfect. Right, so we've got a good answer that we've taken care just to make sure that we get like a really pretty answer at the end. So that's really nice, right? So we've got radius. So now we've got that smaller radius, which means now we can go back to our initial problem. Our initial problem was we couldn't find the arc AD, we couldn't find DC, we couldn't find AB. So now we get back to those. So the arc AD is equal to r times theta. Now we know what our radius is. It's 4. You multiply it by the theta. The theta is going to be 2 pi over 5. Right? So your answer is going to be equal to 8 over 5. We'll just write that as 8 pi over 5. All right, cool, nice. Because remember, you don't want to round off because they said in terms of pi. So we're going to write all our answers in terms of pi. Nice. So the next thing we need to get, so now we have this. The next thing we need to get is DC and AB, which are equal, right? So DC and AB are equal because this side, A to C, is 15. O to C is 15. O to D, now we know, is 4. So this is the remainder of that distance, which we now know is going to be 15 minus 4, which is going to be 11. So how we're going to write that is DC is equal to AB. They're both exactly the same. And that's equal to 15, which is the 4 radius, the radius of the big sector, minus the smaller radius, which is 4. So therefore, that answer is equal to 11 centimeters. This is also in centimeters. This is also in centimeters. Perfect. Now, that means now we can find the perimeter. You can now plug in, right? So all we need is the arc length of AD, which we know is 8 pi over 5, plus plus AB, which is 11, plus DC, which is also 11, plus the arc length BC, which is 6 pi. If I mixed up the letters, I apologize. But anyway, so we have 2 numbers that are in terms of pi, right? Which we need to make sure that we isolate. We have this one and we have this one. I meant this as a plus sign. My apologies. Right, so we have those 2, which we can isolate, but we can work out these other ones over here, right? So this one and this one, 11 plus 11, this is going to give us 22. And then we can add our 6, so 6 pi plus 8 over 5 pi. That is, so I can just add 6 plus, in my calculator, 6 plus 8 over 5, because all I'm doing is I'm going to say, okay, factor out the pi, and then all you're left with is 6 plus 8 over 5. That is going to give you 38 over 5 pi, or 38 pi over 5. And all of this is in centimeters. Maybe let's just do this, just to show this is our number, this is our unit. All right, cool. So essentially, let me just see if you can just add 6 pi plus 8 pi over 5. You get exactly the same answer. Yeah, so you could have just plugged this into your calculator directly. But yeah, that was a very interesting question. But that's how we can break that question down. Hopefully this kind of makes sense. And this approach wasn't confusing. If it was, please do let me know, and I can try to explain it a little bit better. But yeah, I will see you in the next video.